Good evening. Welcome back to my channel called Mental. Today I'm going to do another live stream, and it's a continuation of the Python course. I finished module 2 last week, which was about functions. Today I'm going to complete the module 3, which is Booleans and Conditionals. Okay, so okay, I'm not 100% sure this is actually working correctly. I think there might be a lag. It's something I don't know for sure until I finish the stream. And if that's the case, I will re-upload later on. Okay, right. So let's start. Python has a type of variable called bool. It has two possible values, true and false. X equal to true, and then print X, then print type of X. So the first print statement is going to print the actual value of the variable, which in this case is a bool true, and the third statement, the print statement, is going to actually print the type of the variable, which is bool. Rather than putting true or false directly in our code, we usually get Boolean values from Boolean operators. These are operators that answer yes or no questions, and we'll go through some of these operators below. Comparison operations. A equals to B. So normally a comparison is always with a double equal, because if you use a single equal sign, normally that's an assignment of one value to another, of one variable to another variable. So that's why we normally use the double equal sign, so we don't confuse with an assignment. If you want to say two variables are different, is A different from B, you use exclamation mark, which means not. And then, so the second symbol is equals. In this case, we use the single equals because there's no doubt. When you look at these two symbols together, it means not equals. And that doesn't get confused with an assignment. So A not equal to B. A less than B, as you probably learned in mathematics, this means that A as a number, for example, is less than B as a number. And then you have the opposite, which is A is bigger than B. If you want to have A less than and equal or equal to B, then you have to add the equal sign here. A less than or equal to B, and then you have the opposite, which is A bigger or equal to B. Okay, so we have here an example of a method. Can run for president, age, the usual Java, the usual documentation of the method here. Can someone of the given age run for president in the United States? And the US Constitution says you must be at least 35 years old. So our test is age bigger than or equal to 35. And then you can ask some questions using the method. Can a 19-year-old run for president? And this would return. So can run for president 19. So let's see what happens. In this case, you receive age as a parameter, then you apply the bigger than equals to sign to the age variable, and then you pass in the 35 here, and the result is a bool parameter. So the result of this, 19 bigger than or equal to 35, is false. So the first print statement is going to return false. So the second print statement, can a 45-year-old run for president? Let's see, 45 bigger than or equal to 35, that's true, then returns true. So that will be true. So now we can maybe make just, well, the course is showing an example of a very obvious comparison, but this could sometimes go wrong because this is a float. I think in Python is a fractional, well, it's a float, and this is an int, which means, well, but they are the same value, so it should return true. But now let's make it a bit more tricky. What if it was a string? So the string value of 3 compared to 3, and the result is false. And the reason is this is a string, and then actually a string does normally convert to an integer, and the ASCII code for 3 is actually not 3. But if you think about it, it doesn't make any sense. This is actually a different type. This is just a string, and this is an int. Right? Okay. So comparison operators can be combined with the arithmetic operators we've already seen to express a virtually limitless range of mathematical tests. For example, we can check if a number is odd by checking that the modulus with 2 returns 1. This is a very standard test. So an odd number, when it's divided by 2, will always have a reminder. And this is why we use the modulus sign here. And it should always be 1 reminder. It's either 0 or 1. So 100, is 100 odd? No. So this should return false. Is -1 odd? No. Yes, because the reminder is 1. And here, this is something I've highlighted before. Remember to use equals equals instead of equal when making comparisons. If you write n equals 2, you are asking about the value of n. When you write n equals to 2, you are changing the value of n. You're making actually an assignment. How do you combine Boolean values? You can combine Boolean values using the standard concept of and, or, and not. In fact, the words to do this are and, or, and not. With these, we can make our can run for president more accurate. Can run for president with an age and then a parameter is natural born citizen. So we check if is natural born citizen is true, and then we combine this check with another check which we had developed before, which is age bigger than or equal to 35. And the result is print can run for president 19 of true, it's false. Can run for president 55, sorry, I think well, hang on. So yeah, this one will be false because he's 19. Even though he's a citizen. The second one will return, so 55 is okay, the age is bigger than or equal to 35, but because he's not a citizen, then this is going to fail, so it's going to return false overall, because we are using and. And the third one, finally, so his age is 55, which complies with this clause, and then he's a citizen, so a natural born citizen. So that returns true. So let's see a combination of variables. So this is this, if you want Boolean logic, you understand how to answer this question. So it's actually interesting because if I'm not, so there is here the question of order of, in this case, which operator has precedence? And or? Well, I think if I'm not mistaken, it's and that takes precedence. So if in order to do this calculation, I have to do true and false. So something can't be true and false at the same time, so it's going to be false. But then you have true or false, which is always true. So let's see if I was right about the order of operations. Okay, so I was right. Let's see if I was right for the right reasons. So we need to figure out the order of operations. For example, AND is evaluated before OR. That's correct. So that's what I had said just now. And that's why the first expression above is true. If we evaluated from left to right, we would have calculated true or true, which is true, and then taken the AND of that result with false, giving a final result of false. You could try and remember this rule, right? In practice, as he is suggesting, I never do. I always use brackets because I don't like to. It's always good to make your code readable, even though with a bit of mathematics you can write less characters. But the more expression you can put into your code, the more easy it is to read. So the best rule of thumb for me, at least, is to add brackets, even though I might not need it. So here is saying the same thing I've just described. It's good for preventing bugs, because sometimes you might get it wrong. And it's also makes intentions clear to anyone who reads your code, so it's easier and more expressive, your code. So let's see an example. Prepared for weather. Have umbrella or rain level less than 5, and have hood or not rain level bigger than 0, and is work day. To be honest, I've already got myself lost. We could figure it out. So let's do precedence. So rain level bigger than less than 5, and have hood. That would have to be calculated first, and then this one as well. Then overall could be calculated together. But you know, so there is a bug anyway in this code. I didn't even try to read this code because, to be honest, it's painful. And I think anyone who sees this code will feel some pain. Okay. So by adding some brackets or parentheses, so prepare for weather has an umbrella, or rain level is less than 5 and you have a hood, or if it's a work day, who cares? It's you in the office anyway, so you don't need to worry about the weather. I'm a bit confused. Oh, the opposite, actually. I think not rain. So this is actually a little bit hard to read, but this is basically saying it's raining and it's a work day. And then here is negating, which means if you apply this to this, it means it's not raining or it's not a work day. Okay, so here's a bit easy to read because we're separated. Conditionals. Okay, so because we learn about Booleans, but you know, you don't learn about Booleans on its own. normally whenever you have a Boolean, you have a condition. So normally you'll find that Booleans are using conditional statements, and the keywords that you will use a lot is if, elif, and else. We've used an if statement earlier in the course, so this is not going to be new to you. So this method is inspecting a value of x. It prints is 0 if x is equal to 0. It prints x is positive if x is bigger than 0. If x is less than 0, it prints x is negative. And finally, if none of these conditions are true, then else will call this method, which will be a print, and print will print x is unlike anything I've ever seen. So if we call this method with 0, then it's going to print 0 is 0. If we call inspect with -15, it will say -15 is negative. elif is actually a shorthand notation for else if, which you might find in Java or other languages. You don't need to have elif or else in the if statement, but quite often you'll find them anyway. When you want to specify what to do inside an elif, you can specify the columns and then some empty white spaces in the next lines to denote a block of code. Here is an example of calling f with, okay, so this is the method definition, the function definition. If x is bigger than 0, we print only printed when x is positive, x equal to 1. So, and the second statement will also be printed. I also only printed when x is positive, x equal to x. It's kind of repeating it. Then outside the if statement, print always printed regardless of x value, x equal to x. In this case is 1. So the first call is going to call these 3 print statements. And this is the ones that it did. The second one is only going to call this statement here, which is here. Okay, let's talk about Boolean conversions. We've seen int, which turns things into ints, and float, which turns things into float. So you might not be surprised to hear that Python has a bool function which turns things into bools. So in this case, the first line of code prints bool of 1. So any positive numbers are treated as true, and this can be handy, except 0, of course. So if you print bool of 0, that's going to return a false. If you print bool of ASF, these are strings. If you have a non-empty string, it's a positive, it's true. If you have an empty string, it's a negative, it's false. So this is going to return false. And normally this is because this is handy when you're dealing with sequences like lists, strings, and other types, tuples. So if you want to easily check if a list has elements or not, you can just convert it to a bool, and this saves you from checking the length like that. We can use non-Boolean objects in if conditions and other places where a Boolean would be expected, and Python will implicitly treat them as their corresponding Boolean value. So this is where sometimes it can be confusing, and if you're not careful, you might end up making a mistake, because the problem is, okay, this is handy, can be useful that an int will directly can be used as a bool because it's converted into a bool using the bool function. But if you don't have to specify that, then you might give it an integer by mistake and then your code doesn't work. So I don't necessarily like this, because maybe it was going to lead to bugs. But that's how Python works. So it's good to be aware. So if 0 is an integer, that's going to be false, so this is not going to print. If spam is a non-empty string, it's going to print spam. Okay, so now we've finished the theory, and let's go to the exercises. Let's see. Okay. So let's run the setup code. Start slow today. Right, so let's start with the exercises. So it's saying here, many programming languages have sign available as a built-in function. Python doesn't, but we can define our own. In a cell below, define a function named sign, which takes a numerical argument and returns -1 if it's negative, 1 if it's positive, and 0 if it's 0. Okay. So, definition of function, def, signed, with the open the brackets to receive an argument. So I'm going to call it number. So that's two ways, I think. So the first way, if I want to be really specific, I can convert the number to a Boolean. And we know that if the number is negative or 0, it's going to return false. Oh, hang on. This is different. Okay, so I didn't read it properly. So it returns -1 if it's negative, 1 if it's positive, and 0 if it's 0. Well, we could do this with a if statement. Let's do that, just to make it more. If number bigger than 0, return 1. Else if, which in Python is elif, number less than 0, we return -1. Or else we return zero. So yeah, this should be the easiest. It's correct. And let's see if my solution was as smart as solution or not. Maybe there's an easier way. Let's see. There's always a different way. So I've done more or less what they wanted. Well, exactly what they wanted. Okay. So, second question. We've decided to add logging to our toSmash function from the previous exercise. So in this case we mean print statements. And the question is, what happens if we call it with total candies equal to 1? So toSmash. So it's going to print split total candies 1, and then it's going to do 1 divided 1, and this is a reminder sign or the and 1 divided by 3, the remainder of 1 divided by 3 is basically 1, because the only one that takes, I only can use 0, and 0 is, so if I was actually doing an integer division of this by 3, it would be 0, the remainder is 1, so it's going to return 1. Yes, because splitting total candies, so 1, splitting 1 candies. This isn't good grammar, and is asking now to modify definition in a cell below to correct the grammar of the print statement. If there's only one candy, we should only use the singular candy instead of the plural candies. So this is where this statement comes along, without trying to be too clever. So I'm just going to do if total candies bigger than 1, I use the plural, else print singular. Splitting. I'm hoping nobody's going to return to pass in a negative number. I'm assuming nobody does that. Splitting 1 candy. Okay, sorry, I got my grammar wrong. Should be candy with a Y. I thought that was. Okay, now the solution should be correct. Actually, the more correct seems like some of this. But it should be the same, because this is probably it's the same anyway, but no, it's just a different way to write it. So third question. In the main lesson we talked about deciding whether we are prepared for the weather. I said that I'm safe from today's weather if I have an umbrella or if the rain isn't too heavy and I have a hood. Otherwise, I'm fine unless it's raining and it's a work day. The function below uses our first attempt at turning this logic into a Python expression. I claim that there was a bug in that code. Can you find it? To prove that prepare for weather is buggy, come up with a set of inputs where either the function returns false but should have returned true, or the function returned true but should have returned false. To get credit for completing this question, your code should return a correct result. Okay, so we need to find out what's wrong with this method, because if you remember well, it didn't have brackets. So if I want to, we know that there is precedence of the and over the or, and we have two hands here. So if I set is workday equal to false, this is going to return false. Wow, it's confusing. I think that this takes precedence of the and because there's a not. So this is false. And then so if is workday is false, so not rain level bigger than 0. So if rain is 5, for example, is bigger than 0, then not of 5 bigger than 0 is, well, 5 bigger than 0 is true, not true is false. So this is going to return false even if is workday is true. So false. So rem is bigger, 5 less than 5 is false, so this also returns false. Okay, I think it's 5. So true or 5 less than 5 is false, true or false, but then this takes priority. So if I put false, so I want to return true, false, but when is workday. Okay, I'm going to add, so I don't see the bug here. So I'm prepared for weather. If I have an umbrella, or if I don't have an umbrella, then the rain level is less than 5. And have a hood. Or if the rain level is bigger than 0, or not, or if not, or if the rain level is less than equal to 0, which is the result of adding the not, and it's a workday. I need to find out where the So I'm prepared for weather for sure if I have an umbrella, right? Regardless whether it's raining or not. Or if the rain level is less than 5 and I have a hood. Or the rain level is basically 0 and it's a work day. I think this is the one. And the problem is the not applies to this. So if I put a rain level a positive number, this is it. So this should have brackets. And because it doesn't have brackets, the not is applying to rain level. So if I say rain level 5, 5 bigger than 0, and is workday true, this should be false. But because okay, no. So I'm going to put false. And it should return false. Should return true. If I return false, if I set to false, okay, so I got it, right? So if I say everything is negative, there's no rain, there's no umbrella, there's no hood, and it's not work day, then this should actually return true, but it returns false. That's the case that is failing. Okay. So it took me a while to get this one. Okay, I've heard the answer, but it took, you see like how long it took me to figure this out. So if you don't use brackets, the bugs can be difficult to spot. Right, number 4. The function is negative below is implemented correctly. It returns true if the given number is negative and false otherwise. However, it's more verbose than it needs to be. We can actually reduce the number of lines of this code in this function by 75% while keeping the same behavior. See if you can come up with an equivalent body that uses just one line of code and put it in the function concise is negative. Hint, you don't even need Python ternary syntax. I'm already guessing what it is. So earlier on we talked about ways of converting a number to a bool. So if we play with that fact, let's just remember, right? If I apply bool to this number, if the number is positive, bigger than 0, it's going to return true. But if it's 0, it's going to return false. Or if it's negative, it's going to return false. So basically it's testing if a number is positive. Okay, so let's see if I can do this one. So let's try return bool of number. Okay, but this is going to be the opposite of what we want. So let me try a not. And I can try and use not. So not of bool of number. So if if number is positive, bigger than 0, it's going to return true. And in that case, it's not negative, right? If number is equal to 0, it's going to return false. So is negative is going to return true. But that's not what you want, right? So how do we solve that edge case? How about we add an extra number plus 1, so that if the number is 0, it also returns true. But what if it was -1? Yeah, -1 would also work, because -1 plus 1 is 0, bool of 0 is false. So I would say it's this. So basically, it's not very pretty, right? And then we know, yeah, this is the answer, I think. No, I got it wrong. What happened there? So my number, oh sorry, I made a mistake. Okay, so -100 plus 1 is -99. Well, I can always invert it, right? So number, so So minus 100 plus 1 is minus 99, and this should return false. So so if it's 0 plus 1, it should return true, but it should return false. Okay. It's minus 1. Trying to be too smart. So 0 is kind of messing up. But it should be something like this, right? Okay. Well, okay, I'm not going to try to be smart. I think it's proven that I'm not smart in this case. So I'm just going to do AND. So I'm just going to be very simple. Bool of number and number equal to and different from 0. So basically what I'm saying is if a number, and basically I'm defining, I'm defining a positive number, which is a number, basically bool of number will give me that, except I want to also include, well, this definition doesn't include 0, so here I include 0. So this is my definition of a positive number. So the definition of a negative number is a not of this. So that should work. So I'm not sure what's going on now. Okay, let's do this without. I'm not entirely sure why I'm complicating so much. Number. I was trying to use a fancy notation, but actually let's just do this. I don't know why I was thinking. Sorry, I don't know what I was saying. Well, this is the normal easy answer, and I was trying to use the bool type to convert something to a number, to a boolean, but I didn't need to do that. So yeah, what's wrong there? So next question. Okay, let's see if I can finish this off a bit quicker. So let's see if the actual solution was any fancier than what I did. So next one, the Boolean variables ketchup, mustard, and onion represent whether a customer wants a particular topping on their hot dog. We want to implement a number of Boolean functions that correspond to some yes or no questions about the customer's order. For example, onionless, ketchup, mustard, and onion, and returns whether the customer doesn't want onions. Okay. So this means there is no onion. So if onion is equal to false, then it returns true. Okay. So wants all toppings. So returns whether the customer wants the works all 3 toppings. So that means they want ketchup, mustard, and onion. So simple. Return ketchup and mustard and onion. Okay, next one. Method is wants plain hot dog. So a plain hot dog doesn't have any toppings. So ketchup, mustard, and onion will all have to be false. So in this case, return not ketchup and not mustard and not onion. Done. Easy one. So exactly one sauce. So this means that we either only want ketchup, mustard, or onion, but no more than that. So So basically, so I'm going to try and use the conversion of a boolean to an int and see if I can get away with it. If I remember well, I can convert ketchup to an int. Number of toppings, I can define it as int ketchup plus int mustard plus int onion. So if ketchup is true, int will be equal to 1. If ketchup is false, int will be equal to 0, and so on. So return number of toppings equal to 1, and that's it. So this is where it's actually useful to convert types. Well, so let me just see if I made a mistake. On my assumption. So first one, so wait, hang on, I made a mistake. So what here considers a sauce is either ketchup or mustard. Onion is not a sauce, so I need to remove this from here. Okay. So now it's okay. So let's see what solution they came up with. So just to see if I did something easier or less. Okay, because it was only 2, then it's actually easy to do a return statement like that. So that's why my solution was also okay, because I converted to an integer. Okay, question number 6. We've seen that calling bool on an integer returns false if it's equal to 0 and true otherwise. What happens if we call int on a bool? Try it out in the notebook cell below. We already know that because I've just done it. Can you take advantage of this to write a succinct function that corresponds to the English sentence? Does the customer want exactly 1 topping? And I've already done that. And let me just, I'm going to copy it. Okay, the other one was sauce. Exactly one sauce. And now it's actually exactly one topping, which includes onion. So I need to put int onion and return and toppings equal to 1. And it should be okay. It works. So last question. Hopefully. Oh, it's not exactly the last question. Okay, let's see what this says. In this problem, we'll be working with a simplified version of Blackjack, aka 21. In this version, there's only one player who you'll control and the dealer. Play proceeds as follows. The player is dealt 2 face-up cards and the dealer is dealt 1 face-up card. The player may ask to be dealt another card, hit as many times as they wish. If the sum of their cards exceeds 21, they lose the round immediately. The dealer then deals additional cards to himself until either the sum of the dealer's cards exceeds 21, in which case the player wins the round, and the sum of the dealer's cards is greater than or equal to 17. If the player's total is greater than the dealer's, the player wins. Otherwise, the dealer wins, even in the case of a tie. When calculating the sum of cards, Jack, Queen, and King count for 10. Aces can count as 1 or 11 when referring to a player's total above. We mean the largest total that can be made without exceeding 21. So, for example, a plus 8 equal to 19, a plus 8 plus 8 equals 17. For this problem, you'll write a function representing the player's decision-making strategy in this game. We've provided a very unintelligent implementation below. Okay, so I'm going to stop for now, and I'll continue in another video. Thank you for watching, and in the next live stream I'll be continuing this notebook, and I'll be a little bit more fresh to actually do this game. And looking forward to having you again in this live stream. Thank you so much, and have a lovely evening. Bye-bye.